Good day, friends.
Each QC tool will be discussed in detail to understand quickly, so watch till end to understand the concept of 7 QC tools. Discussed topic will be, what are QC tools? What are 7 type of QC tools? Which chart to choose? Why 7 QC tools? Benefits of 7 QC tools? What are 7 QC tools? 7 QC are statistical tools used to collect data, control, brainstorming, analyze, and see the trend of a process, service, etc., by individual, business, organization to improve or solve the quality problem. Cause and effect diagram, fishbone diagram or Ishikawa diagram, identifies many possible causes for an effect or problem and sorts ideas into useful categories. Check sheet, a structured, prepared form for collecting and analyzing data, a generic tool that can be adapted for a wide variety of purposes. Control chart, graph used to study how a process changes over time. Comparing current data to historical control limits leads to conclusions about whether the process variation is consistent, in control, or is unpredictable, out of control, affected by special causes of variation. Histogram, the most commonly used graph for showing frequency distributions, or how often each different value in a set of data occurs. Pareto chart, a bar graph that shows which factors are more significant. Scatter diagram, graphs pairs of numerical data, one variable on each axis, to look for a relationship. Stratification or flowchart or run chart. A technique that separates data gathered from a variety of sources so that patterns can be seen. Cause and effect diagram, fishbone diagram helps in identifying the potential causes of an effect or a problem in respective categories. It also helps in understanding the areas of opportunity through effective brainstorming. It take up 2 points, first possible root cause, second brainstorming. This concept work on man, machine, material, environment, measurement, method. These are the possible cause of a problem and root cause can be identified by brainstorming for these. Man, it is a major contributor in manufacturing industry like training, means operator have less skill or training for the required job. Shift is a contributing factor to an error because with each shift the operator changes training, shift, fatigue of an operator also contribute to an error because fatigue contribute to alertness. Operator himself is a contributor because required skill necessary for a job. Material, and if used material is not of right quality, then there will be possible errors like alloy composition. For example, if we have to deep draw a metal sheet, then deep draw material is required, then draw material which have different composition. Lubrication, if material is not used with proper lubrication oil, then there will be flow in part. Supplier, any material from supplier will also contribute to error because different supplier have different procedure to produce the material. Measurement, inspector skill also contribute to checking method of a part. Calibration, if instrument used is not calibrated, then there will also be error. Machine, speed of machine may cause errors, so set parameters required to produce a good part. Overload on machine will cause some flaws in part produced. Tool wear out will also produce defective part if not calibrated or replaced timely. Vibration, bearing broken of machine was vibration result in defective part. Method, angle, operation sequence, die, fixture. The correct sequence of operation, die, or fixture should be used to produce good part. Environment, temperature, dust, airflow, humidity also play major contribution in the parameter set. So these are also necessary to be adjusted as per requirement. Which control chart should depends upon the data we capture, continuous or discrete data. If continuous data and sample size n is equal to 1, then XMR chart. If n is equal to call and greater than 1, then we use or chart. If sample size n is greater than 1, then is chart. If data is discrete data, then defects per unit is countable. If multiple defects per unit, then sample size is constant. Then you see chart sample size is not constant, then use you thought. If defects per unit is 1 and T sample size is constant, then NP chart, and if sample size is not constant, then we use P chart. Control chart. Control charts are used to study how the processes have changed over a period of time, comparing current data to historical control limits. Either the process variation is consistent, under control, or unpredictable by special causes of variation. X chart, the subset of averages or means. S chart displays the subgroup ranges. R chart shows the subgroup standard deviations. Benefits used in SPC study to take decision, quarantine and 100% check, adjust the process, determine if there are improvement opportunities, or prevent unnecessary changes, measure and assess the performance of equipment, standardize manufacturing processes. Control chart is bar chart used for characteristics that can be measured on a continuous scale, such as weight, temperature, thickness, etc. The R chart shows the sample range, which represents the difference between the highest and lowest value in each sample, and monitors process variability at regular intervals from a process, and in the X bar chart, the y-axis tracks the degree to which the deviation of the tested attribute is acceptable. The x-axis on the X-bar chart tracks the samples tested. Together, X-bar and R charts are quality control charts used in conjunction to keep track of the mean and variation of a process using samples gathered over a period of time. Attribute charts, P chart, is also known as the control chart for proportions. It is generally used to analyze the proportions of non-conforming or defective items in a process. A P-chart is an attributes control chart used with data collected in subgroups of varying sizes. The process attribute, or characteristic, is always described in a yes, or by no, pass by fail, to go, and by no-go form. For example, use a P-chart to plot the proportion of incomplete insurance claim forms received weekly. Where lot size is 20, total sample size is 23,040. And no if total defective is 346. P equal to total number of defectives, divided by total number of items sampled. No of lots K, equal to 20E and bar, equal to summation N divided by K, equal to 23,040 divided by 20, equal to 1152. Now, compute P bar, equal to total number of defectives, divided by total number of samples, so 346 divided by 23040, which computes 0.015. So P bar is 0.015. 1 minus P bar equals 0.98. Now let us take the assumptions of attribute charts, P chart. First, the probability of nonconformance is the same for each item. There should be two events, pass or fail, and they are mutually exclusive. Each unit is independent of the other. The testing procedure should be the same for each. C chart is one of the quality control charts used to track the number of defects in a product of constant size. C chart takes into account the number of defects in each defective unit or in a given sample. C chart requires that each subgroup sample size be the same. Now how to compute C bar. It is calculated by total number of defects, divided by sample size. In the taken example, a no of lots, K is 20, and summation C is 326, and C bar is equal to summation C divided by K, that means 326 divided by 20, and the result is 16.3. Now, let us calculate the upper control limit and lower control limit. Upper control limit is calculated by C plus 3 under root of C, means 16.3 plus 3 under root 16.3, and result is 28.4. Lower control limit is calculated by C minus 3 under root of C, here means 16.3 minus 3 under root 16.3, and result is 4.19. What is the use of control chart? First, a quality control chart is a graphical representation of whether a firm's products or processes are meeting their intended specifications. Second, if problems appear to arise, the quality control chart can be used to identify the degree by which they vary from those specifications and help in error correction. Third, a common depiction of the quality control chart is the X-bar chart, where the y-axis tracks variance of the tested attribute is acceptable in a univariate or multivariate manner. A histogram is a bar graph-like representation of data that buckets a range of classes into columns along the horizontal x-axis. The vertical y-axis represents the number count or percentage of occurrences in the data for each column. Y-axis. The y-axis shows the number of times that the values occurred within the intervals set by the x-axis. X-axis show the scale of values which the measurements fall under. Positively and negative skewed distribution. When the data has a range boundary on the left-hand side of the histogram. For example, a boundary of 0 and negative than 100. A random distribution, it can be the case that different data properties were combined. Therefore, the data should be separated and analyzed separately. Bimodal distribution, there are two peaks. In a bimodal distribution, the data should be separated and analyzed as separate normal distributions. In the example we can see that there are 3 customers waiting between 1 and 35 seconds, there are 5 customers waiting between 1 and 40 seconds, there are 5 customers waiting between 1 and 45 seconds, there are 5 customers waiting between 1 and 50 seconds, there are 2 customers waiting between 1 and 55 seconds. Now, we can conclude that the majority of customers wait between 35.1 and 50 seconds. We can analyze the date to reduce the waiting time up to 50 seconds from maximum of 55 seconds by taking different and corrective countermeasure and furthermore. Pareto analysis statistically separates a limited number of input factors, either desirable or undesirable, which have the greatest impact on an outcome. Pareto analysis is premised on the idea that 80% of a project's benefit can be achieved by doing 20% of the work, or, conversely 80% of problems can be traced to 20% of the causes. Pareto analysis shows that a disproportionate improvement can be achieved by ranking various causes of a problem and concentrating on the solutions with the largest impact. Pareto charts can sharpen problem-solving and decision-making skills. Benefits of Pareto charts. 1. A Pareto chart is a combination of a bar graph and a line graph. Notice the presence of both bars and a line on the Pareto chart below. 2. Each bar usually represents a type of defect or problem. The height of the bar represents any important unit of measure, often the frequency of occurrence or cost. 3. The bars are presented in descending order, from tallest to shortest. Therefore, you can see which defects are more frequent at a glance. 4. The line represents the cumulative percentage of defects. 5. In manufacturing, Pareto charts are used as a quality management tool. They help analyze and prioritize issue resolution. 6. The Pareto principle can analyze Pareto charts, also known as the 80-20 rule. The Pareto principle states that 80% of the results are determined by 20% of the causes. So eliminate the problems come in 80%, which will reduce the defect to has the potential to remove the majority of all defects. Therefore, you should try to find the 20% of defect types that cause 80% of all defects. A scatter diagram is used to examine the relationship between both the axes, x and y, with one variable. A scatter diagram or scatter plot gives an idea of the nature of relationship. If all the points stretch in one line, then the correlation is perfect and is in unity. However, if the scatter points are widely scattered throughout the line, then the correlation is said to be low. If the scatter points rest near a line or on a line, then the correlation is said to be linear. Type of correlation. First, positive, in this case pattern of observations slant from lower left to upper right of the chart. When a value of independent variable gets increased, as a result value of dependent variable also gets increased. For example, productivity of a team member gets increased with its experience. Second, negative, in this case pattern of observations slant from upper left to lower right of the chart. Value of dependent variable gets to decrease if value of independent variable gets the increase. For example, number of farm workers in country, decreasing in years. Third, null, there is no correlation between two variables and observations are scattered into the chart. For example, this is baseless to find correlation in number of vacations sanctioned to a team member as per their height. The positive and negative correlation can be further categorized like strong positive correlation. The value of dependent variable clearly increases as the value of independence increases. Weak positive correlation. The value of dependent variable increases slightly as the value of independent variable increases. Strong negative correlation. The value of dependent variable clearly decreases as the value of independent variable increases. Weak negative correction. The value of dependent variable decreases slightly as the value of independent variable increases. Complex correlation. The value of dependent variable seems to be related to the independent variable. Usage of scatter diagram. A scatter diagram is used to understand the influence of the independent variable to the dependent variable, and what is the best fit to get the desired value of the dependent variable. Scatter diagram is used in plan quality process as a preventive approach with the help of historical records to set quality policies for the independent variable to get the desired value of the dependent variable. A scatter diagram is used in control quality process as a corrective action approach to understand causes of poor performance of dependent variable due to independent variable effect. To conclude, a scatter plot is a mechanism to understand the influence of independent variable over dependent variable. Stratification. Stratification is the act of sorting data, people, and objects into distinct groups or layers. It is a technique used in combination with other data analysis tools. When data from a variety of sources or categories have been lumped together, the meaning of the data can be difficult to see. This data collection and analysis technique separates the data so that patterns can be seen. It helps determine whether the problem is confined to a specific subgroup. It gives you insight into why the problem exists. It lets you compare groups with respect to some aspects. It makes it easier to understand results. Stratification helps in analyzing quality cost. Internal failure cost, external failure cost, prevention cost, appraisal cost. This is an analytic tool where you manipulate data by dividing it into subgroups and studying the characteristics of that subgroup. You can use other tools such as histogram along with stratification. A flowchart is a diagram that shows each step or progression of a process in sequential order. The process flowchart or communication flowchart illustrate how a process works or plan a project with a process flowchart. The workflow chart or workflow diagram understand how data and documents flow within your organization. The swim lane flowchart describe how separate departments, processes or employees interact. The data flowchart see where data flows in and out of an information system with a data flow diagram. A check sheet is a structured, prepared form for collecting and analyzing data. When TO use a check sheet, when data can be observed and collected repeatedly by the same person or at the same location. When collecting data on the frequency or patterns of events, problems, defects, defect location, defect causes, or similar issues. When collecting data from a production process. Why 7QC? In today's customer-centric market, quality is an integral factor in the growth and sustainability of any business. Hence, efficient quality management, which has the highest impact on customer experience, is one of the most essential features for any business. So, businesses who want to ensure competitive and excellent quality of their products and services can utilize the proven 7QC tools for structuring a strategic plan for quality improvement. Benefits of 7QC tools? Provides a more structured path for problem solving and quality improvement, easy to understand as well as implement yet extremely effective, a scientific and logical approach for problem solving, improve the quality of product and services, helps in identifying and analyzing problems during the process, follows the 80/20 rule, i.e. gain 80% result with 20% efforts, fishbone training aids in root cause analysis and problem solving, identifies root cause and solve it permanently. Encourages team spirit and fosters a healthy culture, enhance customer experience and customer satisfaction. Thanks for watching the video. Please like, share the video and subscribe the channel.